airlines who were mentioned specifically in these bilateral agreements. So bilateral agreements between, for instance, UK and EU would mean that British carriers like IAG and that's British Airways, or for instance, Air France were allowed to fly between the UK and the EU. For Air France, it's not Paris necessarily, it's anywhere in the EU, yeah? Or the bilateral between UK and Egypt allowed the carriers like Egypt Air and again British Airways to fly reciprocally between the two destinations of Cairo and London Heathrow. Right, and all these details were very much defined and set in the agreements. For instance, for flying between London and Cairo, but not between Manchester and Cairo. That would be just a very different agreement if they wanted to. Not between Edinburgh and Alexandria, but again London and Cairo. And just the destinations were defined, what operators it was well defined, and the frequencies and the number of passengers was also well defined. So the one carrier from UK could not carry more than X number of passengers to Egypt unless there was some amendment to the agreement allowing them to do so. So route networks and capacity limits is something what I just mentioned. The frequency is very much associated with the number of passengers, because the more frequently you fly, the more chance you have to carry more people, etc. Aircraft types also are associated primarily with the capacity. So if Egypt Air is allowed only to fly, or is capable only to fly whichever type is there, it's the A320 most likely, from Cairo to London. Most likely the UK carrier, British Airways, may not be allowed to fly Boeing 777, which is at least twice as big, or even A380, which is 3 times as big, from London to Cairo, because it certainly will carry more passengers. It will make more money on the passengers compared to the Egyptian counterpart, Egypt Air. So they also have to be reciprocal in terms of the capacity which they can use. Again, unless it is somehow defined in the agreement that, well, for instance, the Egyptian party may not consider bigger aircraft on the UK side as a disadvantage for themselves, for instance. But if they maybe are able to fly 2 A320s in one day with only one 777 in one day reciprocally, right? Predetermination of fares, that was also, a pretty typical story when you actually couldn't as an operator on one side, you couldn't dump prices to put the other party into the competitive disadvantage and grab all the traffic to your aircraft with the much better prices compared to your competitor flying from the opposite destination. What they call here revenue pooling is another word for code sharing. So that is when airlines could come into agreement, for instance, to allow passengers paying to one airline fly on another airline, right? But it was primarily the element of reciprocity. So you couldn't expect anything until it is reciprocal and until it is also beneficial for the opposite party. All right, we mentioned the arrangement here. Solution. Applied to all the airlines. So you couldn't go a step to the right or a step to the left without breaking the law as it was operating at that time in the last century, in the previous century. And so some of the highlights you see here, and well, it was not, well, again, all these arrangements, which were regulatory, were introduced with, as they call it in legal, bona fide, or bona fide, with a good intention to help the operators. But at the same time, well, when you limit the operation of commercial business, in which environment commercial business prefer to operate generally, not talking about airlines, generally, as a business which is not government organization, but just a private company? Would you want to be operating in the environment where you have lots of limiters and lots of prohibitions and not don't do it? Right? Which would you prefer? The obvious choice for any company, yeah? And that is the advantage of what they call the market economy, right? Compared to any other political systems. Same last year. So, well, it's as it used to be, it was not exactly the market economy, yeah? Because, well, there was no market. You had this channel within which you could operate, but you couldn't move into other channels. Even you saw that there was some commercial opportunity for you just to make more money, to expand your business, etc. Right? So that was the point of the deregulation, why it happened. So on the left-hand side, it's the regulated era, which is actually an antonym, the opposite to the free market. So, which means that with this revolutionary legislature, the United States allowed any airline fly anywhere they like, wherever they like, they could make additional business. Well, just one word, yeah? So, you can set any price which you think is fair, and it's your own risk, yeah? Because if you go too high in price, you may hurt yourself. Nobody will buy the tickets. If you go too low, you may not make the margin. That's another risk. So you still need to fluctuate between the certain limits, but now it's the airline which is setting the limits, not the government. Yeah? And that's the huge difference because, well, the limits may be wider, maybe narrower, maybe this way, maybe that way, but it's all now defined by the market, not by the government. And again, I'm often referring to comparison between, well, things in general, but now talking about things in general, anything which is controlled and regulated by government in terms of the business, by definition is less efficient than when it is well, run by the business itself, by the company operating in the particular industry. Just because, well, you normally do not have so many resources in the government to be that efficient. And these resources are only in the market. So the free pricing is one of the advantages now. Open routes, yeah. You don't need to ask the government, the federal government, to allow, for instance, the Pan American to fly between New York and Atlanta, and for the American Airlines to fly from Atlanta to New York, and that's the end of the story. Now, anybody can fly between New York and Atlanta if they believe it makes commercial sense for them. just as a result of this free pricing, the airlines were able to reduce price. And, well, you could easily guess what happened. If prices went down, there were more people willing to fly. Right? So it was a great move for the airline industry generally, because it allowed the industry to expand. And as a result of that, since many people saw that, well, wow, that's a lucrative business, that's a profitable business. Let's just forget pharmaceuticals. Let's go into the airlines as a business. You can make money in there as well. Right now that you have more opportunities to do it. So everybody rushed into the airline business. Well, that was a major push that made the air travel market a totally different market in the United States. So it gave more freedom to airlines and it reciprocally gave more freedom for passengers to select between airlines. So it was not just some kind of monopoly or duopoly in the previous days when you had only to choose between American Airlines and Pan American, for example, right? But you have the whole array of offerings from all kinds of guys who were just offering all kinds of tariffs and tickets associated with different circumstances in which you buy the tickets. What followed in Europe quickly was about the same thing, but it coincided luckily with the formation of the European Union. So now we already mentioned that European Union actually made one big single country from the airline perspective. So all of a sudden everybody was flying domestically. There was no Air France as the French carrier. Air France was just the European carrier. And that was a totally different proposition, and it went in stages, as you can see it from this slide. But well, it was in the same direction as it was in the United States. What evolved as a result of that is, for example, the low-cost carriers, which wouldn't have been able to operate in the historically different world, right? But well, what the low carriers need, the low-cost carriers need, is just the freedom to choose, the ability to fly from what destination they want to whatever destination they want. And to carry as many passengers as they think it is reasonable from the commercial perspective. Here we are just a bit expanding on the concept of low-cost carriers as the result of that major political development in Europe in the first place. But well, it was quickly copied by other operators. So Southwest, if you Latvia now is the US low-cost carrier, a very successful airline, just because it was successfully using this model and consistently. Consistently, I mean no exclusions or deviations, but you always go by the same rule which you established for yourself when you're in business. Right? Now, well, just to go through these elements quickly, and also just for the purpose of making sure that you understand the terms. No frills. That's the typical description of low-cost airlines. How do you understand no frills? Just curious. You heard this word? No? You haven't? Okay, all right. No. Good, you'll hear it from me then. Frills, that is, just something great. Yeah, so well, some perks, perks again. It's some goodies, bonuses, benefits, which you get when you fly. For instance, what benefits you get when you fly with the flag carrier, with the traditional airline? Well, you may fly business class, in comfortable seats, with a great food served to you. Well, you have some privileges when you board the aircraft, when you disembark the aircraft. You have the privilege of using the business lounge, for example. Yeah, so well, these are all frills. And you may get some additional goodies like bigger screen on your entertainment system. You can use the flat bed that is actually turning your seat into the comfortable bed when you fly on a long route, etc. And you can get, for instance, food and drinks like that. Yeah, that's one of the advantages. Whenever you want, they will bring it over to you. In Ryanair, if you flew it ever, or if you flew Wizz Air, wherever EasyJet, or Latvia, low-cost carriers, you wouldn't find that. Yeah? Or if you want food, you pay for that. With a flag carrier, you sort of pay for that, but it's just built into the price of the ticket, so it's a different account. The high utilization, that is how frequently you use the aircraft. We will talk about the aircraft economics a bit later, but just to preempt that, as we already noted, aircraft are expensive machinery, yeah, which costs dozens of millions of dollars. And one of the consequences of that price is that when the aircraft is sitting on the ground, it's a cost for the airline. It's just only the negative economics. When the aircraft flies, not empty, of course, but flies with the passengers, that's the whole business for which the airline is doing. And so that's the revenue, and that hopefully may even bring you the profit. So the simple conclusion is, how much do you want aircraft to fly per day? If it was technically possible. So let's just assume the economic consideration. As an economist in the airline, how much would you want the aircraft to fly during the day?
If there's always passengers on board 24 hours.
Exactly, yeah. If it were possible, practically possible, the best solution for any airline would it be to fly passengers, not empty of course, to fly passengers 24/7, etc. You can multiply. Yeah? So the more aircraft is in the air, again with the important caveat, in the air with the passengers who paid for the seats, the more advantageous for the airline, the better businesses for the airline, right? So that's exactly what it relates to. Some airlines fly just one flight a day, which is I don't know, 2 or 3 hours, or at best it's just a flight and return, so 4 hours per day. That's not very efficient use of the aircraft. The aircraft are actually designed really to fly 24/7. It's just the other limiters which do not allow them to do so. Yeah. So, well, if you can fly 8 hours per day, that's better. If you can fly 12 hours per day, that's super. So, well, some airlines just do that. So, well, they fly between 12 to 15 hours per day, and that's actually how they manage to make money. Yeah. So, well, if you fly just 4 hours per day, you will have to spread all the cost of that aircraft through the small hours which you use that aircraft during the years, right? And that's the price of the 1 hour flight would be, right? If you fly instead of 4 hours, 15 hours per day, that's a very different economics. And then the cost of the hour is much, much less, and it allows you to make profit even with this expensive equipment. And actually that's the only way to make profit, to keep the aircraft in the air, as they say it, as much as possible. Well, with certain assumptions, I guess, of course, that the aircraft is full of passengers. Quick turns, or that turnarounds. Turns, that means aircraft like Ryanair lands in Riga, and in 25 minutes they want this aircraft to be leaving the airport for the same reason. These are all connected, right? Because well, the more aircraft is on the ground being serviced, well, cleaning and fueling, passengers slowly leaving, slowly getting in, it all comes into money for the airline as an operator. So that's why they are always stimulating the passengers to do it quicker, and they are stimulating all the services around the aircraft to do it quicker, right? Because it boils down to money. We mentioned the secondary airports because by definition Heathrow is more expensive than Stansted, using the UK examples. just because, well, it's the main airport, it's pretty expensive there to build it there, and well, it's traditionally the best airport, and that's why they claim more charges for the airlines or per passenger, but again the airlines have to pay. If you land in Luton or City of London, in the airport in the middle of London, that's a different price for the airline, and well, certainly that is the price which is more attractive for guys like Ryanair and Wizz Air, etc. Normally it's a single aircraft type, but that's already changing. So well, they are trying to get away from that model, and some airlines are using the model of wide bodies, flying like low costers. For instance, well, the North Atlantic, the Norwegian operator, which operates the wide-body aircraft 787s, is trying to follow that model. But again, the rest of the rules apply, so they want as much utilization as possible, no frills, quick turns. So the rest of the elements of the low-cost model apply. The difference is just the type of aircraft. It's bigger aircraft and flying bigger distances. And these are the challenges. Because of the distances, you may not be able to have that flexibility with the selecting the routes, for example, and using the good and bad times during the day, etc. So there are some limitations which go with the distance. Point to point is, yes, that's one of the characteristics of the low-cost carriers, because, well, that's simpler, right? Well, you remember if, okay, yeah, we will talk about it perhaps also. But we will just continue with the low costers. So if some hiccup happens at one of these points in the hub, as we told, it may affect the whole network, because you are short of aircraft, short of crews. Aircraft do not arrive at the time when they need for the next flight, etc. So the whole system collapses if there is a delay somewhere for whatever reason. Right? So well, then it's a risk. With the point-to-point, it's a much smaller risk, of course, because well, if there's a delay in Manchester on the route between Manchester and Liverpool, it's just this route which is affected, but not the whole network of the UK flights or European flights or the other. But in both cases, again, well, to continue the main subject today, that is the forced deregulation. So in both cases, both models were actually able to emerge as the result of the deregulation revolution. Yeah, so well, the low-costers were able to appear like mushrooms, after regulation, because regulation wouldn't allow them to operate like they do now. And the hub-focused operators wouldn't be able to operate that network again, just because regulation wouldn't allow them. So there are bonuses and downsides to this new world. Yeah, so the bonus was that the number of airlines mushroomed. Right? So there were just a dozen pre-regulation, then there was over 100 after regulation if you talk about the US market. Then it all sorted out and reduced. Not to the original small numbers, but yes, it reduced significantly if we talk about the United States. But this time around, it was not driven by the governments. No government said, okay, you live, you die. Yes, it was just the market. If you can service the passengers better, you live. If you don't do that, sorry guys. Right, so, well, that's how the market forces worked. So they arrived to the same order of numbers, but through a different route, not by edict, not by rule, but just by the Darwin's law, right? The best survive, and the best are those who serve the passengers better, because the only paying turf is the passengers. So what were the reasons for the market forces this time around to sort it out between the airlines? Well, obviously the competition, and they call them emphatically the price wars. So when airlines competed on the same routes for the same passengers through price. Yeah, so Delta was offering the tickets for, I don't know, well, some $20 lower than the American Airlines on the same route between the two American cities. And certainly they attracted the passengers this way. Did they attract enough passengers to make ends meet? That's a different story, and we'll talk about it later today. But, well, that was one of the instruments which was easily available to all airlines. Okay, I want to kill those guys. And I often have these conversations with my customers. We want to kill those guys. Okay, how much money do we have to spare? All right, we have 10 million. We can live on 10 million for, say, 3 months with the way the operation goes. Would our competitor be able to live on the same similar price? Maybe not. Let's try it. So one airline goes with the decreased ticket price. The other airline actually has no option because passengers will not fly them for the higher price. So they have to reciprocate. And well, towards the end of the third month, you see if the other guys survived and you have no cash. Well, well, tough life. Okay, you'll start from scratch. If the other guys didn't survive, super. Yeah, you control that market, but not for long, because otherwise other guys will step in quickly. So that's how the liquid airline air transport world works. There is no empty space which could generate money. So if you don't control your costs, other things may follow. So well, if there's any hiccup, political or natural, like any hiccup which prevents people traveling, whatever stops people traveling, that's a killer for the airlines, right? Because, well, that's the only way they can survive if they carry passengers. The other element is the price of one of the most substantial elements in the costs that airlines have to pay. And again, I will be referring to costs in a few moments. So, for instance, like these 2 months, yeah, so well, everybody is really much concerned in the airline world. How are they going to survive the increased price of a barrel and respectively the increased price of the jet fuel, which already went twice as much in some destinations. Looking at the goodies, well, the airlines could just make them operate in whatever more efficient ways they selected. So they merged, they cooperated, they created all kinds of alliances, etc. I will talk alliances in the next slide. So, well, all this was sorted out by the market. And as a result of this market filtering the strongest against the weakest, they arrived maybe to the same scenario where they started from back in the 60s or 70s of the last century, but from a very different angle, right? So it's now not the government again, I'm repeating myself, but it's the market and all the environment which dictated how and who operates in this market. Right. Now, briefly to continue with just one element of this new market arrangement is the formation of alliances. So at least there are 3 major ones, that is the Star Alliance, to which is Lufthansa the main party, like the head name, the head brand. There's One World Alliance, so that not the spelling, it's just in one word, One World. And the key player here is British Airways. And the Sky Team, with the key operator Delta Airlines. So in each of these alliances, as you can see the numbers, there's many more participants. Why do they make it? It's all on the left-hand side. It's just one of the ways to attract passengers. So somehow it may be similar to the hub and spoke, but it's not directly overlapping. In any case, if you belong, well, if you commit to one alliance, like you carry the frequent flyer card of SkyTeam, for example. Punching in the numbers of that card when you're buying a ticket with one of the SkyTeam members, you already have the advantage, because you may be accumulating free miles which you will use afterwards. You know how the system works. And that is the stimulus. So now it's not just the airline versus airline competing, but it's the alliance versus alliance. Bigger group against another bigger group. And that is based on the loyalty of the passengers. So the primary driver is still the passenger. There are other drivers like synergy between the airlines. They may coordinate lots of commercial decisions. They can coordinate slots between themselves over each other's terms, because they will be damaging the whole system that they are setting up. And it's getting more and more complicated, to be 100% bulletproof and efficient. Yet, generally, it is more efficient. Well, and actually, you have no other way to operate now. If you are not member of any of these gangs, you'll be kicked out quickly by the market. Yeah? If you are operating on your own, or unless you are running a sizable system by yourself, like the low-costers, like Ryanair. They are not member of any alliance. They are the alliance by themselves. Yeah, but that's a different model. Okay, so I guess that's as much as I wanted to share on this subject. Now, we are getting more and more towards the money side of the business. Let's look at the money side. I'm not putting you too much to sleep, talking too much, but I'd rather just share as much as I can with you and so one thing we know about material part of the airlines is that they stay with the expensive flights, and that defines lots of processes and structures out of the business. Some of the ways we already mentioned. They want to use the aircraft as much as possible. Maybe just to wake you up a bit, a quick question. if you look at let's use a different color. If you look at, if you compare these are the two types of aircraft from the same family, as you can see. CO is the previous generation, Neo is new generation. The abbreviations actually mean current engine option and new engine option, right? So the current engine option uses the engines which which were designed and started to be manufactured back in the last century, and the new engine option was designed in this century, and it's just different and certainly technological models. As this is the older model versus the newer model, certainly the price-wise, which would be more expensive, which would be cheaper, CO or Neo. It's old model, it's new model. So the old Volkswagen versus the same or similar model of the new Volkswagen. Same analogy. Which price would be smaller?
The current.
The current one, right? Obviously, yeah. So well, that's there's no brainer, right? As they say. But well, if you throw in other things like more fuel consumption, more maintenance, and well, likewise what they call the maintenance holiday here. You don't have to go to shop and do much on the spare parts. That's already a different equation, yeah? So, well, it may be less in price, but it may be more costly to operate. And that's where the GOC's comparison may help the airline to make the right decision. Is it still okay to operate the old version, or should I try to get as early as possible an order with Airbus for the new version? As early as possible is the caveat that I will explain also in some other later classes. In any case, so the price of the asset is not just the only parameter by which airlines should evaluate the efficiency, the financial efficiency of their assets. If we just put this into the financial plane or financial dimension. So there's that's the traditional standard set of variables which define very much the operating cost of the aircraft. For instance, ownership is by far not the largest element if you spread it over time. Let's assume that normally the aircraft is expected to be in service for at least some 18-20 years before it goes into the graveyard, into the desert, or just cut up into metal. Well, that's not the most important consideration. There are other considerations which would be driving the airlines thinking, well, what is the better option for me to do? And for instance, if you see the general share of the fuel cost element in this pie, even without knowing the numbers, but knowing the trends, if looking at the current market situation with what is happening in the Middle East and with the price of the barrel of oil, what would be the preference of airlines in selecting between SEAL and NEO? Well, just look at the pie of the GOCs again. Any preference, any change in the strategy? Yeah, well, I'm not asking you to do the financial analysis and comparison here, but well, if you just look at the trends. So with the trend of the barrel of oil going up significantly from $70 to $110 or around as it is now, right?
The NEO is better
Yeah, why?
because of the fuel costs, so the NEO will be more efficient, so it needs less fuel and the maintenance is less, and that's why it will be cheaper.
Right. Yeah, so well, if you look, for instance, just looking at this pie, if you look at, if you take the NEO for reference, well, the price of fuel for SEAL would be like this, like 50% maybe, yeah? And the other costs don't go away either, right? So, well, it will be the bigger pie with the fuel share substantially bigger relative to the other elements, which would be maybe about the same. So, well, we just for theoretical assumption, we might assume that the rest of the elements would not be much different. They will be actually, but well, if we just focus on fuel, it will be already an indicator. So that's where the crowd will run for. The crowd of the airlines, I mean. So everybody will want more new technology aircraft because it's substantial saving on fuel. I could tell you that the difference between CEO and NEO, just in terms of fuel consumption, is about 15%. NEO is 15% more efficient compared to CEO. So it will take 15% more fuel on the route between London to Cairo, for example, the examples that we used. And if you multiply that by the number of flights, by the number of flying hours first, number of flights per day, per year, etc., that will be significant difference. So, well, the differences normally are measured in millions of dollars for the medium-sized airlines. So DOCs are a very important element of the analysis of the airline, any airline which is operating the aircraft. Quickly, what constitutes the crew costs? Even if airlines sort of acquire pilots already carrying the pilot license. So normally pilots pay for their license by themselves, just for the promotion of their career. But they need to do the recurrent training pretty often, about at least half a year, or at least once a year, that's for sure. And that's already the airline cost. Well, of course, paying the salaries. Pilots normally good money, as you know. Cabin crew maybe not as good, but there are more of them. And so again, the salary element is important. Maintenance is another element where this balance will be different. So that will be this way. So in any case, the older aircraft, that's the rule of thumb. The older aircraft require more maintenance, and that's why they require more money for maintenance. How it happens, we will see up there now. So ownership costs is, in other words, how much it costs to buy aircraft and to finance it. Normally, airlines don't buy aircraft just for cash. Yeah, so well, it's a very unusual arrangement. I know just a couple of airlines in the world, and one of them that we are, as an institute here, are doing some business that is in Brunei. You may not even know this name. It's in the Southeast Asia, and it's a small emirate, sort of, with the same economy as Saudi Arabia, for example. So all the economy is based on oil, and not many people. So they can afford just to buy aircraft, not finance. But well, that's more of an exclusion rather than the rule. So well, normally in the rest of the world, airlines buy aircraft by financing those. Different ways of financing, and again, I will discuss that with you in later stages. But it all boils down to ownership. No matter how much you finance, well, you spend money, and you spread it into the balance sheet as a cost, which is part of the direct operating costs. fees and charges, that is what you have to pay when you use the air traffic control, the airport services, all these kind of services when you operate the aircraft. So this is not the exhaustive list, but well, I just fleshed out the most typical elements in that list. So well, that is in more detail. You will see it later. What I wanted to arrive at is this diagram. I hope you recognize it. It's the diagram of the typical layout of an aircraft. In this case, it's like a single aisle because it's 6 seats in a row. So it might be, so it's 737-800, but this could be also the A320 by the same token. Here's further digging down and detailing how the economics of the aircraft works. So, when airline sells tickets for their flight, they actually are trying to fill up these seats and to make, assuming that the blue color denotes paid seats. So obviously the airlines are trying to make as many seats blue as possible according to the symbols of this diagram. So the more seats are sold, well, that's pretty obvious, that's no brainer, right? The other practical consideration is that in the real world it's very seldom when airlines can hope for this ideal situation. 100 seats are sold. Yeah, there are some days and many seasons when it happens, but it's not regular. So, well, normally they sell somewhere between the 50% and the 75 or 80% of the seats if they operate in the normal environment and if they have a normal operating analysis for that. So in our case here, they sold 120 seats. The total amount of seats is 125. So there are 55 empty seats, and this translates into this parameter, which I would like you also to remember very well. Load factor. Well, I think that it's pretty transparent why it's called this way. Load. Load is how much passenger load the aircraft has. Right? And the further economics and the further analysis is also involving this load factor. The other terms that would be important to remember: available seat kilometers. Well, in the Anglo-Saxon world, it's often also used as available seat miles instead of kilometers. ASP or ASM. And revenue passenger kilometers or revenue passenger miles. So the difference is, okay, can you quickly tell me how many available seats there are in this diagram?
175.
Yeah. how many revenue seats there are in this lane.
120.
120.
120.
So, and if you multiply these seats by the number of kilometers or miles, you get another metric. That's available seat miles. Available seat kilometers. That is, well, the number of seats multiplied by the distance in whatever measure you get it. Right? Why the distance matters? Well, again, it's no-brainer. There's an obvious difference between the 1 hour flight and the 2 hours flight, and normally you would expect to pay more for the ticket, which is 2 hours flight, than 1 hour flight, right? Unless there is some promotion, but that is exceptional situations. So that is another factor which influences the movement of the needle. The load factor is used just for more sophisticated calculations when you have these two numbers, the available seats and the available revenue seats, or if you have the total number of seats and you just apply the load factor, and it gives you the shortcut to calculate the profitability. Now, again, the question for testing, I hope you know enough about aviation business to be able to answer that. Is the load factor of Ryanair and Air France, for example, typically the same? If you compare just the networks of Air France, KLM and Ryanair, and there's an average load factor, which is just the average of all the load factors on all the aircraft in the fleet, right? So this is pretty convenient to compare. Just two numbers. Load factor for average load factor for Air France and average load factor for Ryanair. Would you expect them to be the same, knowing the model of business?
I would expect the load factor from Ryanair to be higher because the tickets are cheaper.
Well, you just named the root cause, but well, the load factors of Ryanair, like any low coster, is trying to be close to 100, yeah, because that's actually the key way they make money. Yeah? If you sell cheap, you need more of that, compared to if you sell expensive, you can afford few of those, right, like Air France. So that's how it works here also. And if, for instance, you compare by the same token, now it's an easy answer, the charter flight and the scheduled flight, which is regular, every day you have to fly between Riga and Paris, summer and winter, whatever the season, holidays, no holidays, you have to fly because you're on schedule. you have to fly. But the charters, they don't have to fly every day here. They just fly when they have enough passengers. So by definition again, charter operations are close, normally or typically they're close to 100%. And again, that's what allows them to charge a lower price for the ticket. Well, what I would like you to quickly take a look at is another file, and well, I think that you can play with that on your own at your leisure time. So here I have created the interactive file, which addresses some of the key elements of the direct operating cost, comparing low cost in Southwest, which is the famous low cost in the United States, and the traditional, the flag carrier, United Airlines. Well, and you can see that these numbers in the bottom, well, don't be too strict on them because, well, they are just more or less theoretical. But, for instance, if you, for example, change the fuel price for one of the operators, see what happens. How the direct operating costs change in terms of ratio and in terms of the absolute numbers. Same story here. So it will be a very different economics. If, for instance, Southwest uses an older aircraft, so in here it's assumed as 600 per hour. It's more applicable for the new 737. If you look at the 737, which is a 10 or 15 years older, then again, that's the number of the profit. Yeah, so well, your profit will go down if the price of the maintenance go up. So that's the reverse correlation. Right. If, for instance, the United buys a new aircraft and puts this into this operation, so the maintenance cost will be helping the airline to improve the direct operating costs calculus generally. Yeah. It will certainly have a different impact on the ownership cost, if you recall, which was some 12% generally. But well, at least in terms of the, yeah, and actually in terms of the fuel price. Yeah, so well, yeah, I better not touch the fuel price because it's not related to the utilization. It's just related to the price of the barrel. But for instance, you can play with another variable, that is the load factor. if they carry smaller number of passengers, the profitability again will be lower. And well, that's immediately affecting the ratio in the direct operating costs of airlines. Okay, so well, I will also upload this HTML file into the model, so you will be able to play with the numbers and see how the relationship changes respectively. Okay, so well, that's about it for today. What I would like to give you some advance notice that we will now start with the next class some kind of quick tests now that you are accumulating more and more knowledge about the subject. So be prepared to check just the lectures and generally the subjects and materials that we have covered. So I will try to address specifically those not stepping into new classes, it wouldn't be fair, but it would be fair to check how you apply the stuff that we have discussed. So it shouldn't be long tests, it's just the quickest, the quizzes sort of. But be prepared for those and look into this. Okay. Questions? Good. Yeah. See you next time.
You uploaded it, right?
Not yet. I will. And as I mentioned earlier today, that's still need to upload lecture. I haven't done it yet. But well, the first lecture is there. Critical multiple choice, I still need to send you forward more appropriate for the subject.
Все делаем. Давай. Здорово.
So, how do you do?
No, it will be.
What are you doing?
I'm on a YouTube live.
What?
I'm on a YouTube live.
YouTube live?
Live.
Online live. Oh, live the video.
Yeah.
For what?
Oh, for my entertainment. For my entertainment.
Huh?
No, I'm just doing a challenge.
Live stream, you mean it?
Yeah. It's my chat box.
How many people? Oh, 29.
29 is for now. Yeah.
Also, you have
Yeah, I started it since.
you have your own channel, right? In on
Oh.
YouTube, you have your own channel.
Yeah, I have my own channel. I'm just trying to
Did
do
they
something.
hear? Did they hear something that we are talking?
Yeah.
Right?
Yeah.
Oh,
Wait. We can. Done. Yes.
oh, see, he also said they also saw the.
What do you mean?
They also see me and you.
Yeah. Yeah.
How? Oh,
They
I
can
see.
hear what we are talking.
Okay.
I'm doing this just for fun.
Oh, but it's not.
Yeah. When I'm in a lecture, sometimes I feel sleepy. So I won't cut this feeling by doing this. No, I'm just kidding.
No, I mean, don't talk loudly.
Why?
Don't talk loudly because he can. Yeah.
It's okay, I think.
But,
It's okay with that.
but next lecture we will have a test.
We will have a test.
Yeah? You don't know it? Next lecture we will have a test.
I don't remember.
But he just said.
Oh no,
He just said yes.
this one.
Yeah.
Okay, yeah, I heard it.
Mm.
And what about Pavitra's one?
Hmm?
What about Pavitra's one?
Polish what?
Pavitra's next lecture. Aircraft
I
engine,
grabbed.
engine and construction.
Yeah. No. We don't have any test.
Did you submit that? No, it's my bot.
Hmm?
It's my bot.
Your boss?
Bot.
Ah.
What a reply. Did you submit that? Bye.
No.
Have a nice day. Did you submit that assignment? Ratan's.
Yes.
Is
But
it?
it's not like, I'm not pretty sure that. Like, I don't know what what am I doing actually.
Did you create that airfoil and
Yeah, I also great. I watch on the YouTube.
YouTube?
Hmm?
Do you have that tutorial link on YouTube? I think. If you have, could you please share it?
But honestly, like I don't know what am I doing. Yeah, because I don't understand. I just do it by myself. But okay, create an airfoil
On an Excel sheet.
in Excel.
In Excel.
Yeah, this one.
This one.
Yeah.
Could you please share this with me? You have my number, right?
Hmm?
You have my number, right? WhatsApp number?
Yeah.
Then I can do the same by watching that tutorial.
Okay.
Did you use your own coordinations? Right. We need some coordinations to create that airfoil in the
Coordination?
coordination means chords, like some calculations.
Oh no.
No.
Like we use I use ChatGPT. ChatGPT. Like
Okay.
I asked ChatGPT, like, can you create a code for this equation in for Excel?
Okay.
Yeah, they will create.
Then I can do it also. At the moment we have no viewers. At the moment we have no
I don't see
viewers.
the link. I will take the photo and send to you.
Okay, sure. Thank you.
Okay.
At the moment we have no
I don't see the.
Not seeing a reply.
Did you see it?
Okay, I will check. Thank you. was watching this. So
We had lectures before, yeah.
By the way, last semesters you had already group for practical lessons, right?
yes.
So you will follow with the same groups in this semester. So you will follow 14th will be first lecture, and later along with this and you all will take this job cards regular, you know the drill. Yeah, like last semesters.
But we need to print the job cards.
Yeah, I will ask, try to print, but we will try. And now lectures better. I'm not online with the new professor.
I skipped slide. No.
Now what else?
Actually, so how to say? Yeah, I can do this a lot, but I still
Confused a lot.
Yeah,
Like the lecture flow is not there,
like.
but you were able to understand
But
something.
you know, like I can understand, but I just understand when I back home and I watch it again, I understand. But in the class, I a little just because his accent, a little.
Oh, you have to get used to.
Yeah,
Everybody have
Like-
accent. Not everybody native speakers.
and also like
When you go in fields, there are people from different background, different countries, and
yeah,
you have to get used to. Not everybody. Like,
and also maybe if it's in my own language, I know it, but in English, like, but I don't know it. You understand? Yeah. So sometimes he said.
yeah, everybody have this issue. Everybody have this problem.
So sometimes he said maybe I know it, but in English I don't know. So I, like I don't understand English.
Hi.
Hello.
What are you doing previous lectures? I think previous lectures was normal. It was normal, right? We just not anything special.
What's the subject? Business and something else.
He told that we have an exam next week.
Next week.
Yeah, it's not that much hard one, but like test.
But previous time, you don't have anything.
No,
Because I'm not coming free time. Like 3 days.
no, we didn't have anything.
And which topic you need to know?
I will send you.
You have a Roman key for this subject. Because I don't.
Come, I will show you. Wait, I'll check in Moodle. Oh, what is that? Human factors, no,
Human factors.
not for us. Wait, what?
Open with my key.
Wait,
I don't think.
wait, give me time to open it. basic of aviation businesses, right? This one. I think we don't have enrollment key for that. And also he didn't upload any lecturate, any PPT, any presentation yet. He didn't upload.
Wait, but
Every time.
for this subject we need only text, no? We don't have anything.
No.
Because I didn't see any.
What is that? Oh, I don't know. I think this is the syllabus. Wait a minute. He uploaded. We had like 2, 3, 4, 5, 6 lectures.
And what he said about exam?
No.
Only test like ABCD.
Yeah, everything we done.
Multiple choice.
Everything we have done. Multiple choice. Yeah, probably. It will be MCQ paper or something like online test. Genius. Hey, where's Sanju?
He said that he want to come today.
He asked me about the assignment. He came only for 3 lectures in this semester. He can pay. He's a rich man.
times, and also most part of the engine are with very high temperatures, where even the super alloys which are manufactured for engine parts or the components, even they can melt. Yeah, so that's the reason we require some cooling and cooling system where we subdivide into many. Yeah, so subdivide into many, and how this cooling system is achieved basically, and what are some of the purposes, and how efficiently we try to use this cooling. Yeah, with the bleed air without even disturbing the thrust. Main intention is we have to utilize the bleed air without disturbing or any reduction in the thrust. Yeah, so that's the main idea or the objective, like how we can do this. Yeah, so this is what we need to discuss, and different parts of the engine and accessories require this cooling, how we achieve this by the bleed air. Yeah, so this is what we need to discuss with. Yeah, so we will discuss first of all the application of air systems, or how it is subdivided into, and what are some of these areas where we require engine cooling. Yeah, engine cooling or air system in engine is quite complex because to provide the cooling for each internally and externally of the engine, and also with some of the accessories attached. Yeah, so it is quite complex system. Like equally complex, we can say, like how we utilize the air for efficiency of the engine. Yeah, so how we use for actual working of the engine, similar way, similar complexity with the air system, which is actually used for this cooling. Yeah, so this is what main objective or some of these applications were used. So first of all, if we think of applications, where and what are the accessories separately we require this cooling systems. Yeah, so this is what the question arises. Basically, we subdivide into external cooling, internal cooling, and also with the turbine cooling and some of the accessories cooling. And also applications like, for example, we use the same bleed air to mostly for cabin, yeah, basically with the which is called ECS, like environmental control systems. Even this use the bleed air. Also with the anti-icing system. So all these systems basically require some of this bleed air utilization and some of the applications. So most of this used for cooling the engine, and also utilize the bleed air for different applications. So that's what we will discuss each of this parts, sections, how we utilize this bleed air efficiently without reducing any efficiency of the engine. Yeah, so this shouldn't reduce our thrust finally. Yeah, so without this, how we utilize is the question. So first of all, when we classify basically with the engines, what are these applications, or let's check with each of this application. For example, internal cooling. Internal cooling, when it comes to, so where this internal cooling, or what are some of the systems or inside the engine we require this cooling basically. Yeah, and where do we steal or we use this air, or where this air coming from? Yeah, so this is what's the question. So internal cooling, when we say we require cooling for mainly for turbines. Yeah, so turbines, for example, and bearings, seals, yeah, seals, for example, and also engine casing itself, yeah, and inner casing, we can say, inner casing, yeah, inner casing, and next question is where we take this air or where this air is utilized from. So this air comes from basically from compressor, yeah, compressor different stages, compressor different stages, yeah, the different stages. For example, LPC, HPC, yeah. So in this also we classify like high pressure bleed air, low pressure bleed air, and each have different temperatures, and what temperatures is ideal for what cooling also is quite important to understand. Yeah. So this is what is inner cooling, how we or where exactly we require or why we require basically. Yeah. So for example, the turbines, yeah, turbines basically also will have high pressure and low pressure. So turbine section, or we can call it as hot section, which is very much required for this cooling. Yeah. So this turbine section separately gets this air cooling channels from this low pressure and the high pressure type of compressors, which is extracted. Some most, like for example, 5 to 25% is used for turbine cooling itself. Yeah, so 5 to 25% of air is airflow from compressor. Compressor is used for turbine cooling. Yeah. So more than this, we will lose the thrust or the efficiency of the engine. So we have to use the rest of this for actual doing the work for the core of the engine to run the engine. Yeah, so this is what is percentage. We cannot use more than this. Yeah, so this is what is for turbines. We will discuss that how turbine cooling happens. What are the systems inside the turbine or how it is designed, basically for the cooling. Yeah. Next is for bearing and seals. Bearing and seals also require this cooling because of bearings can expand, contract, yeah. So because they are the most, mostly with the hotter section of the engine, and also this bearings usually will have the heavy loads which are acting on the shaft, and they are near the shaft, yeah, mostly. So this bearings also require the cooling. So this also usually provided by this mostly with the LPC and HPC, which is taken from this compressor section. And seals, why we require the seals cooling? Mostly seals are the ones which are actually entitled with the oil inside, and it is with the airtight condition which is holding the oil for lubrication. Yeah, so seals. So instead, if we don't provide this extra cooling or the air which is supplied to it, sometimes it might lead to leaks. Yeah, so this leaks also can cause some of the fires. Some of this during this engine run. So in this case, like, it's quite vital to keep the seals also to have this airflow, which will actually blow out some of the leaks in case, like, if they have any leaks conditions. Yeah. So bearings also are provided with this type of seals and yeah. So cooling. And engine inner casing. So inner casing is where exactly the core of the engine lies, or even with the casing itself. So casing we have checked with already. They have some of the duct holes where this bleed air actually circulates. For example, if we have turbofan bypass, like basically most part is exiting on the outside of the duct, and some parts are exiting or actually utilized, or which will go into the core of the engine. Yeah. So we require this casing where exactly the inner casing, especially where the hot section is. So this casing also requires some of this airflow, and also it requires some cooling. Yeah. So this cooling also is done or taken, utilized from this compressor, low pressure compressor and high pressure compressor section. Yeah. And next is with the external cooling. Yeah. So external cooling. External cooling. So external cooling, what we are talking here is the nasal, pylon, and also the duct, bypass duct basically, which will have this bleed air, and this is what is external cooling. So external cooling is quite important as well, because we have to separate the engine section from the fuselage attached to it or the wing attached to it. Sometimes, depending on the airframe section where it is attached, it's quite important to keep the casing, outer section of the engine also with the cooling system, or we should have this cooling system, because like we have to, in case of any type of compressor surge or in case of fire, usually there are these section systems like where we isolate the fire and try to keep the engine outside section, while if it is it has engine fire also, we can somehow isolate this from the wing structure or with the airframe structure, so that like we avoid some of this fire which is actually catch by the engine. Yeah, so that's why we require this external cooling. So external cooling is for basically for nasal, yeah, pylon, which is actually parts of airframe, yeah, parts of airframe, and some of engine outer section. So engine outer section requires also some of this cooling. What are the significances? We will go in deep later on with pictures and stuff. Yeah. So also where this we extract the air from is by most of them is the bleed air. Yeah, bleed air the pass. Cross section, which is also some part of PC and HPC, but mostly this direct low pressure compressor, high pressure compressor air is directly going into turbine cooling, not the external engine section. Yeah. So this is what is external cooling. Third is for anti-icing system, the anti-icing system. So this also is the complex system we use usually for wing anti-icing external surfaces like control surfaces. Right? So control surface anti-ice, which uses bleed air again. And separately we can say turbine cooling system has its own system inside turbine cooling. That need to discuss separately. It has own cooling system. Which uses PC and HPC. own cooling system, we will check with how the system is, because it's more complex. Yeah, it is vital, very significant to have this cooling. Yeah, or else we might have this superalize which can melt. Yeah, and fifth is basically for something called ECS, or we can say for cabin pressure, cabin air conditioning or pressure. We can say. And then air conditioning. So this is what is application also. SECS is like environmental control system. Environmental. We are talking about the inside the cabin environment. Environmental control. Yeah. This is for cabin air condition, yeah, which utilizes breathe. These are some of the main applications. We can say that we should should have the cooling system, or in all the cases, and for different applications, inner cooling, external cooling, and also this anti-icing system, turbine cooling, and air conditioning, basically. Yeah. So these are all main applications. Each system needs to be discussed, how the airflow, how we utilize the airflow, and from where these actually air, which is coming from, utilized in different sections, internally, externally. Yeah. So this is what is quite important application system. Yeah. So we have to study each one of this section separately to understand how the airflow is inside this. Yeah. So let's check with the internal cooling and sealing. Yeah. So you can see in the picture, basically this is a picture of this twin spool turbojet engine. Yeah, so it has low pressure section, high pressure section. It doesn't have any extra bypass. It has only small bypass, and most of this location of bearings, which is having the loads from this compressor and the turbine section, yeah, which is shown in this. So low pressure compressor, which is driving the low pressure turbine, and the high pressure compressor turning or driving the high pressure turbine. Yeah. So here we have to understand the low pressure and high pressure. Yeah. So there are different types of air which is circulating here. We classify them into low pressure air, which is coming from the low pressure compressor section, and second is high pressure intermediate air, and there is also high pressure air which is from the high pressure compressor. Yeah. So intermediate is basically in between the low pressure and the air which is discharging from the compressor section here. Yeah. So intermediate is what is quite important also. Yeah. So all the air which is actually discharged from this compressor will have a flow through this internal shaft, and also in the bypass section, some of the air which is actually exerted through these holes, or we can say dents, like which are actually made to have the bleed air to circulate and bleed. This is what is the inner casing, yeah, and this is what is the outer casing. So inner casing also require some of the cooling in this section, yeah. So this is what is the inner casing. Separately should have this, yeah. And the airflow which has been discharged, some part of it is actually exiting from the air outlet here from the high pressure compressor section, yeah. So, and also most part which has entered from the high pressure compressor section, it is entering to the turbine section, yeah. So turbine section, basically we have two different types of air which is actually entering there. First section will have the low pressure compressor air, compressed air, which is not actually much higher in temperatures. We can say that it is cool air which is actually exiting, and this air is actually provided near the turbine inlet, which is the stationary stator, and which is actually used to cool down after the combustion chamber. So it requires some temperatures to be cooled, and this low pressure compressed air is quite good for giving this entrance of this turbine to be cooled and in proper condition, basically, yeah. So this is used for stationary section of the turbine, which is like stator or the inlet guided vanes for the turbine section, yeah. From the combustion section, actually the hot gases which are exiting are hitting this turbine, yeah. So for this section we will have high pressure compressed air which supposed to need to be passed through the turbines, because the pressure which is actually having from the high pressure compressed air is quite good enough to enter the turbine section, which is a high pressure turbine, which is like a rotating turbine, yeah. So there are certain cooling channels which are present in the turbine section. It's supposed need to be entered this cooling section. So without the pressure, without the high pressure, it's hard to circulate with the rotating turbine and into the cooling channels inside the turbine. So we use the high pressure compressed air, which is the HP air, going directly to this high pressure turbine section, which is like rotating turbines, yeah. So next question maybe like arises, isn't it quite hot, like when we provide it is meant for cooling, and from the high pressure compressor, isn't it higher temperatures for the turbines? Actually, comparatively from the combustion chamber gases which are exiting, they are quite very high temperatures, up to 1200 to 1500 degrees Celsius, yeah. So comparatively with the high pressure compressor, it is quite high, and if we mix this high pressure compressor air which is entering through, mixing with the turbine which are rotating in the high pressure area, actually these can enter through the cooling channels inside the turbine, and with mixing with the hot gases which are exerted from the combustion chamber, this is quite good enough to keep our turbine cool, and also it will pass on, or it will carry on with the gas path similarly, which after exiting from this turbine cooling sections, yeah. So where does the air go? Basically from this high pressure after cooling, basically it will carry on with the gas path to the exhaust section, yeah. So even near this section, exhaust section also have very high temperatures due to the gases which are exiting from this combustion chamber. So even for cooling, the exhaust section also is quite important, and with this mixing of high pressure compressor to this gases with the flight air path which is exiting from there, this will keep our not just the turbine cool, but also exhaust section, inner section also quite cool, like, or it will try to keep the temperatures, because even there temperatures, suppose it shouldn't go beyond 1700 degrees Celsius near the exhaust. Yeah, so this is the condition. So it will try to maintain this temperature by when we mix some of this high pressure compressed air. Yeah, comparatively from the combustion section to high pressure compressed air is much cooler than the combustion section gases which are exiting from the combustion chamber. So this is how basically the internal cooling system is utilized, or how we use this low pressure compressor and the high pressure compressed air for cooling as well as for work done, basically. Yeah. So we don't require much of this airflow which is entering to the core through the combustion chamber, because combustion requires very less air comparatively, because we have to keep there also the flame continuous. Yeah, so if we provide with much high pressure air inside the combustion chamber, it will blow out the flame. If we provide lower amount of pressure air, then it will not give a flame at all. So for mixing, it is quite important to have appropriate amount of this airflow inside the combustion chamber, and we have to maintain this pressure which is required to have the continuous flame and continuous combustion which is happening without any interruptions. So this is also one of the conditions that we suppose need to have this high pressure we can utilize for this turbine section. Yeah. So how is the air part? Yeah. So let's check, or let's try to like navigate through this. Yeah. How the air part is, or where exactly like it's entering from. What are the systems, or internally how we can utilize this. Yeah. Internal cooling.
Picaboo.
Air part. So, first of all, the air LPC and HPC will enter core of engine. LPC will be utilized for cooling turbine stationary this temperature is ideal. This temperature is ideal for low pressure turbine. air, pressure compressed, discharged air is utilized on high pressure turbine, which is very high temperatures. Yeah. High pressure air is used because to circulate the rotating turbine. Blades. So this high pressure will actually force this air to enter the rotating turbine blades so that it will cool down inside the channels. We have the cooling channels inside. Yeah. So that's how it will utilize this. Yeah. Basically, all this. And some parts of here we can slide that high pressure compressed air is much cooler air compared to gases exiting from combustion chamber. This is what is quite important why we consider the high pressure compressed discharged air to provide it to the high pressure turbine because we need to insert this high pressure, then only it can circulate through this turbine cooling channels and it can cool the turbine section. And also why high pressure compressed air is actually, we can consider that it's much cooler compared to combustion section. Yeah. So and also there is this intermediate air. Yeah. So intermediate air, yeah, which is intermediate air, which is in between, LPC and HPC discharge. Area. And this is used, this is used in our casing. different airs, which is high pressure, intermediate section, low pressure. All this basically used. Also, this intermediate air actually is utilized for cooling this bearing section as well. Yeah, and also low pressure. Yeah, LPC used to cool bearing and seal section. Seal. Seals. Bearing. Bearings are near this hot section. Hot section of the engine. And also these high load bearings on. So it requires also some. So that's how it is utilized, and all the air paths which pass from LPC to HPC, and there are this circulation patterns that have shown where you can see the low pressure and the lighter markings, which is through the airflow. They are entering through the high pressure section, and there is this intermediate section which we utilize for inner casing. Yeah, it is entering through, and also the casing is maintained cool inside the core, and the high pressure discharge, which is in the darker arrow section here, it is entering the turbine, which is the hotter section or high pressure turbine section. Yeah. So that's how actually the air path is in this internal cooling, and where this exits, all the air which is used for cooling basically exits through the gas path, or the enters this exact section of this gas path. Yeah. So finally, it will the cooled air will be discharged to join the gas path. Join gas path near exhaust section. Will also provide some of the cooling for exhaust section as well. Yeah. So that is what is the path which is followed cooling, and basically how it will appear, or how the system works with. Yeah. Where does the cooling come from? This picture basically provides with the image of turbofan engine. Yeah, turbofan with high bypass. Basically, also will have the similar conditions where we have the low pressure fans or which are connected to provide with in high pressure bypass, like for example high bypass turbofan engines, most of the air is actually exiting through the bypass, so which will provide the cooling in this case. So most of this, in this case of turbine, in the first picture what we saw was actually the jet engine without like very high bypass, and in here we have high bypass type of turbofan engine, which will have turbine blades cooled with the compressor discharge air, and there is this low pressure with the other components, for example burner, liner, disc, and also cooled with compressed air. Most of these accessories or the attachments where we can check where there's the cooling air. So it's a similar cooling section or similar cooling way where we can see that the fan provides the ideal cooling for the very hot section, and the high pressure section, which is actually provided with the high pressure turbine section, which will try to enter the rotating turbine blades and will try to cool down this section of the engine basically. So mostly not just with the section of turbines require the cooling, but also for example the combustion chamber also requires some of this cooling. For example the burner, liner, discs, turbine discs, all this require this cooling with the compressed air. So this is quite vital when it comes to for cooling sections within the internal section of this cooling air. So this is what is turbine blade cooling with the compressor discharge air. So when it comes to turbofan gas path, so in this blue section is what is the low pressure compressed air, and which is entering to the turbine section, compressed gases which are exited, and you can see there is the cooling components, and also the orange color which is representing is the high temperature high pressure gases which have entered the turbine section. So the gas path with the turbine turbofan also is very similar. Only thing, the difference is basically with the amount of bypass which it will go on with, and the air, amount of air which is utilized for cooling. Most part is utilized for cooling, and also exiting air from the bleed air, which is actually also act for thrust, which will produce in the turbine section for work done. So this will reduce large amount of noise for the engine. We have discussed this, some of these advantages of having high bypass. Also providing with cooling for most part of this engine section externally. So the turbofan engine cooling air part. So first of all, the air fan is bypassed where it has high bypass. which will be used for external cooling, which is used for external cooling. Secondly, the air from fan entering for engine. Will be sent to turbine section. Section for initial cooling. Also, some of this also for engine accessories like the line is not yet so straight. So this gas part, and finally bypass air, as well as for join the gas pot. Gas pot after cooling. That's the gas pot for basically for turbofan engine. So mostly all the air which is from the bleed air and also from the core usually join the gas pot and it will be exited through the exhaust system. Yeah. So this is how the gas pot in turbofan mostly. So all the bypass air which is with the high bypass will cool the outer section, and inner air will cool the inner section of the core of the engine. Basically. Yeah, so that's how it is utilized. Since most commercial aircraft engines are turbofan, so this is what is used, and mostly we are focusing with the bypass bleed air, which is actually also utilized for cabin pressurization and cabin air conditioning. Yeah, so this is what is the gas path or the utilization. And next, we have to check with what stages of compressor will be used for which section and what is it used for. Yeah. So here it is representation of what section of the compressed air or the compressor we will use for what particular cooling. Yeah, so this also is quite important or significant if we consider. So 7th stage, 8th stage, 11th stage, 14th stage. So in case of high pressure and low pressure compressor, if we have the twin spool, then we suppose we'll have all these stages, which will provide the cooling system a different section, mainly used for different section of the cooling system. Yeah. So for example, the 7th stage, which is from the LPC, this is used for first stage of LPT nozzle, which is at the leading edge cooling. Yeah. So there are also for initial stages of cooling. For example, from the first stage, it's not that high temperatures. So these are actually sent or used for the LPT nozzle, or we can say the leading edge cooling. So there are also different channels which we use for cooling. For example, how the cooled air actually circulates is similar to the wing section or the airfoil section. Yeah. So it passes through the leading edge and later on actually exits through the trailing edge. So that's the similar pattern in the turbine section, turbine blade section, how they actually exit. That we will see what are the channels, how it is used. Yeah. And there is this 8th stage where we have the customer bleed. So this 8th stage is what is actually utilized for the cabin pressurization and also the air conditioning. Yeah, mostly this. So at the 11th stage, basically with the 2nd stage HPT and cooling, which is the again high pressure turbine section cooling, and also with the 14th stage customer bleed, and also with the 1st stage HPT and 2nd stage HPT are blades actually, which is used for cooling the turbine shrouds and also the disc, and also basically where the blades are actually fixed to the disc. Yeah, so this is what is mostly the section where they are used for. And also there is this HP recoup where it is like 1st stage LPT nozzle, trailing edge cooling, and also HP recoup, which is like overboard. Yeah. So this is what is we need to understand what is recoup here. Yeah. So air cooling system, when we consider like HP recoup and LP recoup. So actually, what do you mean by recoup? Yeah. So this is like a recuperation, which is happening within the air circulations. Yeah. So this is a recuperation. Basically, we call in short HP recoup. Yeah. So HP recoup, LP recoup, that is used for low pressure turbine nozzle, trailing edge cooling, and also low pressure recoup, which is used for overboard.
Yes.
Yeah. So this is how basically how the circulation or the most part of the engine section which we utilize for. Yeah. So when we consider the nozzle bleeding air, which is the 7th stage, for example. Yeah. 7th stage, which is the 1st stage of LPT nozzle, leading edge cooling. Yeah. So this mostly used stage turbine leading edge cooling. Edge. So, if we consider the turbine section blade, it is something with this, which is attached to the disc shrouds, for example. So they have actually the surface holes which will provide the circulation, and there is also near the turbine section some of these holes which where through the air exits. So this first stage of air which is entering basically from the second stage of low pressure compressor. So it will enter the leading edge and exit through this trailing edge of the turbine blades. So inside here we have quite a lot of channels. There is another picture slide which will show that, so I'm not going in detail with that, but this is what is used for leading edge. So leading edge of turbine. Section and exiting to trailing edge. So that's how basically the seventh stage, what they meant, the turbine leading edge to the cooling system, which happens, which will circulate through, which will exit, enter the cooled air inside the turbine, and there are certain channels, and it will exit through the trailing edge. So this is what is happening with the seventh stage, like how it enters, basically. And the eighth stage, for example, eighth stage is meant for custom eighth stage, custom bleed. Custom bleed, which is meant for cabin pressurization, and air conditioning. For eighth stage, what I meant is customer bleed or custom bleed which is used. And there is this 11th stage which is used for 11th stage, which is used for both customs bleed plus HPT, turbine blade muscle, which is for high pressure turbine blade muscle cooling. So this is our 11th stage, and the 14th stage basically used for custom bleed, first stage, second stage, and also the shrouds basically with all the high pressure turbine section with the disc, with the shroud, bottom attachment. Yeah, in all these cases, these are some of the sections where we suppose use for fourth stage customer bleed. Customer bleed plus HPT all sections. All sections like shrouds, turbine base, and turbine attachment. So all this HPT turbine section, it will be used, mostly with 14th stage. So these are all some of the important stages, and we have something called HP recoup and something called HP recoup. What does this mean, HP recoup and LP recoup? Basically, any of the leaked air from these sections, so while we are using it for cooling, some of this leaked air or the collected air, which is actually from the cooling section, we will utilize it again, or we are sealing it not to lose the efficiency of the engine. Yeah. So this is called high pressure recoupation. High pressure. High pressure. Short form of any bleed air, suppose not to leak. If it is leaked, then it should be collected back. It should be collected and utilized. Because when we have any type of these leaks can cause some of the unwanted turbulence within the engine, which is not actually convenient. Yeah. So as we know, we have to have all uniform, non-turbulent air basically in the core of the engine from the compressor and from this which is entering the turbine section. Yeah. So this is quite important not to have any recuperation. Short is recoup, we call. Yeah. So all this, any type of leaks, it will be collected and sent it back or collected and utilized for the core section of the engine. Yeah. So for this utilization. So this is what is called recoup, or we can have this type of leaks. Yeah. So when we talk about leaks and when we talk about the bleed air circulation and the air path, there are two different types of air systems, which is like the open loop air system and closed loop air system, which is like circulating, or the bleed air which is actually leaked, suppose need to be collected and sent back or utilized somehow. Yeah. In this case, like we have two different types of this airflow system. One is the open loop and second one is the closed loop. Yeah. So what are these open loop and closed loop type of air path or airflow? Yeah. So let's check with what is open loop and the closed loop air system. Air system, right? Open loop air system. And second is closed loop air system. Closed loop air system. So what are this open loop and closed loop air system? So open loop air system, basically what we saw so far in our engines, this is the open loop where we are not bringing the exiting air from the exhaust or collected air back to the inlet section. Yeah. So this is called the open loop, where the gas flow or the air flow, which is open, basically exiting from the exhaust section. Yeah. Second thing is the closed loop, which is basically it's quite complex, which is not common in the aircraft engines. In this case, basically all the air which has been utilized and also used for cooling system, all this basically has been collected and sent it back with some of the pipelines, channels to the inlet section, so that we will not let this air to exit, but we will utilize this cooled air again back to inlet section, and we will use this cooled air which was circulating. In a sense, like recuperation, basically there is any type of leaks or any type of air, we will not let it out. We will try to bring it back to inlet section and try to utilize this to improve the efficiency of the engine. Yeah. So this is a complex system which is not common in the aircraft. They use for some turbine engines, not for aerospace applications, different applications, because the closed loop mechanism is a very complex design, and to achieve this is a very complex system inside the channels inside, which is used for cooling. Yeah, it requires the separate cooling channels, and to bring back all this recoup from different sections, it's quite hard and a complex system to make it utilize. Yeah. So that's the reason, again, like it's with the extra weight, it's with the complexity, and also mostly, yes, it will improve the efficiency, quite very small part comparatively with the open loop. So mostly we have difficulty with the manufacturing, yeah, because of its complex design, and also could be the weight part, yeah, so it might have extra weight while we provide it with the extra pipeline channels which will bring the air which has been exiting, or the bleed air which is utilized, to bring it back to the intersection. Yeah, so that's the reason basically the closed loop air systems are not actually recommended in airspace use, but they are used for different other applications. We will not go deep into it. Yeah. So some of differences, advantages, disadvantages with the open loop air and the closed loop. Yeah. So open loop system, open loop air system, and closed loop air system. So, first of all, recoup air is exiting the open loop, not have extra weight. Extra peptides benefits and differences with both of this type of airflow system. Closed loop and open loop. So mostly not common with the airspace sections, airspace engines. There are certain other utilization for turbine engines, but not in airspace, yeah, because of its weight and other parameters. And here is again a cross-section view of similar what we have discussed so far, actually from which section what type of air is utilized and how it is benefited with. Yeah. So this is the same sectional view of basically what so far we have discussed with. Alright, so far we have discussed with the internal cooling only, yeah, what is happening internally with the air system, and utilize it efficiently, and how we try to not to lose the efficiency of the engine by utilizing it for cooling systems. Yeah. So now we have to discuss for external cooling and ventilation, which is for fireproof bulkheads, also whole external casing itself. Yeah. So I think we'll take a break and we will start the external cooling ventilation after the break. Yeah. So far, any questions? Yeah. So it's easy to understand. Basically, we have discussed Just we need to check with how, where, what percent, and where this air coming from for the air flow system. Yeah, so this is what. Okay, let's take a break and come back.
Алло, слышишь? Я просто жена будет правильно не называть.
А, нифига, она раньше закончила.
Дома.
5 минут лишь разговаривал.
Ну, в смысле, посмотри. Ну, наверное. Примерно. Ну, у нас как-то редактируем. Потому что обложку сохранили, очень хорошо. Нет, давай обсудим сейчас. Ну все, у меня, короче, свой план, я все это понимаю. Ну и в субботу и воскресенье мы тоже план. В субботу мы идем на Намастhe, в воскресенье мы идем на Bowewa. Ну, хорошо, мне просто на 2 часа надо приехать к вам. А если я смогу ехать с утра, но это тоже будет. Ладно, это мы обсудим.
we have fire in the first section due to engine burst, then this shouldn't actually escalate to rest of the engine, and to have the catch fire with the wings or with the other airframe structure wherever the engine is attached. There are this fireproof bulkhead section. They are like physically separation from this initial midsection and the rear section of the engine. Yeah, so it's a physical isolation for in case of fire, then it will not escalate to other sections. So this is a fireproof bulkheads. They have the separators. Physically, they will separate these sections. Yeah.
ඇටෙත් එක්කම පලාගත්ත නම් තමයි හොඳ.
To isolate.
ඇටෙත් එක්කම කපාගෙන පොඩි පොඩි කෑලි වලට කපලා ඔබ දාලා හොඳට ලුණු දාලා දවසක් විතර තියලා මේ අවුව වේල ගන්නමයි තියෙන්නේ.
This actually is used to release
So please sabarakarai
air which has been
whatever. So please
sabarakarai. In case of compressor stall, in case of compressor stall, there could be some of this bleed air leaks, for example, yeah, which suppose will build some pressure inside this section. So we have to have a pressure relief door in case of this high pressure, yeah, due to this. So we have to release the pressure. This is like automatic door opens when this pressure has been collected or pressure has been built up during this stall, surge, or any case of bleed. Yeah. So that's the reason we do have for the external cooling and ventilation, this fireproof bulkheads, and also with the pressure relief door. Yeah. So these are basically, when we say the fireproof bulkhead, it's the physical separation for fire, and pressure relief wall, it's an automatic door which opens when there is a pressure buildup, and also if there is in case of leaks or any case, like whatever the reason the pressure has been built up. Yeah. So this is what is external cooling and ventilation. Yeah. So let's check with how the gas part of how the air circulates are. What are some of the airflow, how it will actually circulate. Yeah. External cooling usually utilizes some of bypass air. Fire bulkheads. Fireproof bulkheads. physical separation. It can be 2, it can be 3, yeah. Intermediate section also can be actually separated. This is a physical separation. Isolate
उनको देखो
pressure relief wall, which will automatically open the gate of pressure relief ducts. Pressure. External pressure or external cooling and ventilation happens. There are separate fireproof bulkheads will have their own type of fire detection kind of detectors, yeah, and also they will have their own what you call the fire extinguishers, which is fixed, yeah, for each fireproof bulkheads, so that in case of fire they will trigger and they will turn, like they will activate, and they usually turn, yeah. So fire usually will be fire proof bulkheads. Three different sections. There could be 3 different fire extinguisher and also this fire detectors. So these are all some of the fire extinguishers. extinguishing detecting, how we can actually stop in case of engine fire. So these are, we'll discuss that how we protect from in case of fire, how the fire extinguisher will be, or what kind of fire safety exists with the engine itself. So that we will discuss separate lectures. And next, with the external cooling and ventilation, this is basically the air part again, where exactly and how it exists. There are different zones, zone 1, zone 2, so zone 1 basically with one particular bulkhead, and zone 2 with the full second bulkhead. So this is what is the fireproof bulkhead, which looks like separate physical separation, basically, which will not extend or which will isolate the fire in case. So the air circulation, for example, in the zone 1, which is actually taken from this bleed air and from the section of where we have this bypass section, so like air escapes separately with the holes which we can see on the engine casing or the covering. So there are certain dents, holes where we can see that air is entering, and also actually with the high pressure it is exiting. So this is what is the external cooling and ventilation which is happening. And with the external, for example, some of the attachments here, you can see, so these are all extra attachments, also require some of the cooling. So this is what is external cooling and ventilation, which I suppose need to be required or very important if we consider. And this is what is again the fan engine cooling and ventilation, which is showing actually the fireproof bulkhead on the upper section, where exactly and how the air circulates, and the second section, which is from different viewpoints. Basically, you don't see this top view, you are not seeing this pressure relief wall. So first picture what you saw was the side view, where you can see this fireproof like pressure relief doors there. With the second picture, this is basically from the top view, where you will not see this pressure relief wall. With the next picture, also fan engine cooling and ventilation, there are two different pictures for different views. Basically, it's a top view, which will close some of this airflow ventilators. So these are all from the zone 1 and zone 2, which is with the separators, how the airflow separates it. And in here, like there are 3 different zones, separators, basically exhibited with the intermediate section as well, and the cooling and ventilation system. And why do you even come to lectures, in my opinion? Like for morning, like first lecture was very quiet. You enter and like there is already disturbance, and like it's like why? If you are bored, if you are not interested, you don't have to come to lectures at all. Don't disturb. This is not the first time, this is second time I'm on it. You don't have to come for lectures if you're not interested. First lecture was quiet, everything was quiet. You enter and like there is already disturbance, and you get the company, right? Like if you are bored, like I will stop lectures, you study by yourself. Alright, so cooling and ventilation system, turbofan engines. Basically in here you can see the 3 zones, as I mentioned, the physical separation, where there is entering the front firewall, so this is front firewall, for example, for the inlet section, and there is second firewall, radial drive fairings, here you can see, and there is also a rear firewall which will separate actually all this. Yeah. So pylon, splitter, fairings, all these are extra attachments what we usually use to separate these sections. Yeah. Zone 1, Zone 2, yeah. Mostly there are 3 different sections here. So they are separated with ventilation, cooling air, which will circulate. Yeah. Zone 1, Zone 2. So there is a front section, intermediate section, and it's not the same for all types of engine. It could differ from different engines. Yeah. So some can have 2 firewalls, some can have 3 different firewalls depending upon how big the engine is, basically. Yeah. So more the stages, we might have to have more sections for the firewall bulkheads. Yeah. So this is what the system. So usually with the bypass air, what we use for external type of airflow through the unsealed covering, basically. Yeah. So there is this duct which actually huge space between this nozzle covering and the internal core of the engine itself, and it requires extra, basically this nozzle airframe. It's part of airframe, and it's attached to the wing and airframe section where we require this airflow which supposed to keep this airframe mostly requires some equipment. Yeah. So this is what is the zone 1, 2, 3 with the fireproof and ventilation which is required. Yeah. So this is what is cooling and ventilation, which is external cooling. Yeah. So what is most important is this fireproof bulkhead and pressure relief valve, which is automatically opening. Usually it is used to basically to release the pressure, yeah, in case of any pressure buildup. What is pressure buildup? It's the leak from the airflow, and in case of any surge, any stall, also it can happen. Yeah. So this is what is cooling and ventilation. So next is cooling of engine compartment, which is with the similar pictures. It's showing the flow of air in the hot zones, cold zones, separators, yeah, and in terms of how the airflow path, basically, yeah. So airflow path is always from the front to rear, yeah. So airflow actually, which we use, or even for the jet engines, for example, in this case, this is a jet engine where engine is in the rear section of the aircraft. Yeah, you can see the tail part, and we have an exhaust in this case. Yeah. So from where the air circulates, or how the air path is, usually it starts from the front section, which is the cold section, cold zone, and it will move towards the hot zone or the rear section of this engine. Or this is a type of jet engine, basically, where it is separated, or how the airflow is actually shown in this. Yeah. So these are all hot zone to cold zone separators, which is called the fire bulkhead. Yeah. So this is what is the picture for external compartments. There are many similar pictures with the different types of engines. There are different color indication where and how, what type of air flows, basically from the low pressure to high pressure, and to different sections where the air flows. So this is again always the airflow is from the front to rear. There is nothing like which is coming from rear to front. We are not bringing it back because this is a open loop section or open loop type. Yeah. So this is what is the airflow. This is example for CFM 56-3 engine type. Yeah. So this is an example, and the indication is represented with all different types of colors. Where is what types of airflow, and also type of. And here there is something called the cooling system cavities. Yeah. What are these cooling system cavities, basically? Cavities are type of holes, ducts, like near, like we can have this, we can consider that they are used to circulate the air. Yeah, so this is what is cavities. So they also come with the different section, different number of cavities. For example, here you can see A, B, C are types of cavities which you can see. Yeah, and each represented. Yeah, so basically we have different section color representation. Blue in this case. This is the turbine inlet section, front section which is rotating. Yeah, so they have with the casing there are these cavities which escape actually, air circulates through them. So this is what is the C, and here like another section. So type of air cavities which we have in the combustion chamber sections we do have for casing, and also we do have near the combustion section as well. Yeah, so for keeping the combustion chamber cavity, or like to keep cool this combustion chamber, as well as the near this hot section we require the air circulation, so bleed air which is escaping through them. Yeah. So there are certain cavities which have around the hot section. This is the hot section of the engine, air sectional view, and we have different air pressures which are entering from cold section to hot section. Yeah. So this is what is the cooling system cavities, why we require, and these are the places how the air circulates, so the air path circulates. Yeah. So this is what is called the cavities. So different cavities need to be identified then, for example, turbine cavities. This is hot section. Hot section of engine. Which have some air flow cavities. For circulation and cooling. Yeah. So A, which is representing cavity near combustion section. Casing and combustion chamber as well. And there is this B cavity, B and C cavities. Which near one section. Section on circulation. And cooling. This is what is B.Sc cavities. To distinguish them. Okay, next is the typical turbine cooling and sealing. Basically here also there is an airflow section which is actually very high. Yeah. So it's just showing with the cavities like where they are present and how they circulate. As we discussed with the turbine section, they will have leading edge, trailing edge, exiting columns. Yeah, so this is where the turbine cooling and sealing is happening. So you can see that the cool air which is entering actually exiting through the first overboard low pressure air, yeah, which is exiting through, and we do have the hydraulic seals. Basically we have quite a lot different types of seals and bearings which we have discussed before in the components, engine components, why they are and what they're meant for. Yeah. So for in this case, seal actually used to align the shaft section, yeah, which is with the turbine rotating blade sections here. So the cool air from the high pressure compressor section, it is entering through different sections of the turbine. So that's how the cooling air entering. Here is your basically with the nozzle guided vanes which are stationary. There also it's supposed need to enter, and also turbine disc which is actually provided support to the blade, and also the turbine shaft which will provide rotation, and there is this high pressure cooling air dispelled into the gas stream, yeah, as it passes through. So the airflow from the ALP low pressure section will actually exit through the overboard section, and we have high pressure cool air which is entering through the nozzle guided vanes and turbine blades, which is entering or cooling for leading edge and exiting through the trailing edge. Yeah. So this is what is the high pressure cooling air dispelled into the gas stream. Yeah. And there is interstage lubricant seal which is holding for the shaft section. Yeah. And these are all the turbine discs which are supporting the blade section. Yeah. So yes. So it's the just the kind of sectional zoomed view of how the nozzle pre-swirl actually with the airflow occurs, and how the flow is, where it is entering, where it is exiting. Yeah. So these are all typical turbine cooling and sealing. So similar picture, yeah, gas outlet with the different sections, and they have shown from the side view here. So the cool air which is entering actually will provide, yeah, both the way. So this is the gas inlet, actually this is the combustion chamber here, and the exit air which will enter the turbine section. Yeah, these are all the rotating turbines, yeah, and passing through the gas outlet, and we do have basically the air which is exiting will join the gas block, yeah, gas outlet. And here also the air circulation, like cool air, which is cooling these turbine blades, which is from the leading edge and exiting through the trailing edge. And we have to check with how the circulation channels or the cooling channels which are present in turbine section, turbine blade section. And there are different types of cooling channels, different methods, like each cooling channel and the components. It will have a different purpose and different way of cooling, and also how and why these channels exist or exiting. It is quite interesting with the turbine channels. Okay. So this is all about the cooling of gas turbine, which is like external cooling and internal cooling which is shown here. So this is also quite a lot different types of pictures, with the shrouds, hangers, and lower wheel space, upper wheel space. Also inboard cooling air supplies, hot gases, outboard cooling air supplies. So inboard is through the core of the engine, outboard is through the outside section or inside the casing, but outside of the engine. Now, with the more interesting part is with the nozzle, guide vane, and turbine blade cooling arrangements. So this is example for one of the type of single pass internal cooling, like how it has evolved basically. So in 1960s we didn't had any cooling channels inside. There were only some of the cooling air which is directly entering through this shroud and just exiting out with the cooling air outside near this stationary, which is actually supporting with the where we place the blade. But next in 70s we had some of the changes, or some of the cooling system channels which were introduced for better cooling, better efficiency. Also there came into existence some of the super alloys which we use, titanium alloys. So with this it came into existence some of these leading edge and trailing edge holes, which were actually had similar path, where in the leading edge air will enter and on the trailing edge it will exit. So this was actually secondary stage where it has evolved, and we have third stage at the moment. What we have the aircraft turbine blades is these with the internal cooling channels. So we do have internal cooling channels there. So we have kind of leading edge channels, which is like air inlet. It enters through the air inlet holes and it will circulate all through these channels, basically, which is called the serpent. Because of its snake-like structure, it is called the serpent, and like most of the air which has entered, suppose need to circulate in all these sections, and it will finally exit near the trailing edge. So this is what is basically the now what we have the design inside with this. So why we have this is actually more the air stays inside when it circulates through. More air stays inside. It can actually transfer most of the heat to the air and exit with the most of the cooling for the turbine blade. So that's the reason we do have somebody knocked out. This is how basically the latest design which came into existence, like which is called multiple pass multi-feed internal cooling with extensive film cooling. So there are two different types of cooling. One is called the film cooling and other is called impingement. So film cooling, basically it will form a film around the section of the leading edge and the trailing edge while circulating because of its serpent-like structure inside. So this snake-like structure. We have channels like holes which have actually the turbine blade is not a solid type of blade which will have actually these channels, serpent which is called. So these channels actually provide the film which will create the air circulation and the cooling system, which will form some of this air cooling near this, which is formed the film. So film type of cooling, film airflow or film type of cooling And we do have second type impingement, where near the exit, like this is the impingement, where there is no film but it is exiting and joining the gas pump. Yeah. So this is how the turbine cooling, how complex it is and why it is vital. Yeah. So there are certain terminology also we need to understand with significance of turbine cooling. Turbine can withstand temperatures between 1500 degrees Celsius to 1700 degrees Celsius, which is superlice, more than this temperature, superlight melts. We have to maintain the cooling there. Yeah. And secondly, there are two types of cooling. One is film cooling, second is impingement. So film cooling, which forms near the edge of turbine. Enters leading edge section through holes, surface holes, forming okay. Which will exit. start a new film. How this film is formed in the film cooling is by tunnels. Yeah. Film, or mainly what is the difference between the film cooling and the impingement is film formed by cooling tunnels. Channels inside the channel. So that's different types of cooling system. And now we have to check with some of the terminologies for the turbine section cooling. How and what each component of the section, why it is designed such way and what will it create basically. Yeah. So we have this picture here. You can see very determined, like described with a lot of components. Each of these have separate terms, terminology. Yeah. For example, let's try to provide. Each component in aircraft is basically the airfoil section. Some of these shrouds. Air complex section. This terminology, if you see reps, stator for the sea, some of the blade platform. Yeah, so all this. Here also we do have some of these tools, for example. So these are all button platform. So each has its own purpose, terminology if we consider, yeah. For example, leading side or the suction side, yeah. Also, if we have very important is this. Basically, there is this tool inside also where you can see different sections. So actually, if we say that turbine blade is not one solid blade, but we do have hollow sections inside. Yeah. So hollow sections, something like you can see. You these sections. Further this use something for the cross section with turbulation. Pulling through. So rest all you know this on detail. So each section or each component will have its own significances and why it is made so. Yeah. So for example, serpent cooling, or what they call the serpentine cooling channels. Cooling turbine blade. So that here stays longer time. Inside. proper heat exchange. That's the reason we have the cooling channels inside. Yeah. And second component is this rib turbulator. Actually, the airflow, which is from the HVAC, who is entering through the leading edge holes, and actually flow into all these channels, and it will exit the trailing edge. We have something called the rib turbulator at the edge of this. This will create some kind of turbulence. Yeah. So this turbulence is purposely created to have separation because not to disturb the incoming air, and if this separates, and actually this will follow the gas path, and this will also help to cool down some of this hot air and to cool the turbine section itself. Yeah. So there might be a question for you guys that we are creating turbulence, and isn't it inappropriate to create turbulence, and we might have some vibrations there. But in this case, the turbulence percentage is very, very low, and if we think of that after the turbine section, actually turbine section is where that the work is done already. Yeah. So it is exiting air, and the turbulence caused or the extra purposely caused turbulence will not create any trouble for the engine or for its vibration or any such activity. So it is purposely made to separate the airflow from the trailing edge. Yeah. So this is what is the turbulator. Yeah. And there are certain pin, dimple or protrusion, what you call. This is made to exit the air. Yeah. Third component, pin.
blue glow on my face, loading screen haze, half empty glass, unfinished quest. This is my midnight save point, heart on pause, eyes on the frame, drifting through pixel daydreams, all of my worries out of the game. This is my midnight save point, letting the soft waves cover my brain. If I just stay right here, maybe the world can wait. Friends list all gray, messages unsent.